Alright, here we go. We're going to start in about a minute and a half. Keep the schedule. Alright, 9 o'clock. Welcome to Made Up of Wires. We're going to be decompiling Castlevania Symphony of the Night. Castlevania Symphony of the Night was a game for the PlayStation 1, released in 1997 by Konami. It's a Metroidvania style game. The Vania from Metroidvania comes from Castlevania Symphony of the Night, based on exploration, where you play primarily Alucard, Dracula's son. What we're doing in this particular project is looking at the objects that were shipped on the PlayStation disc, the PlayStation Portable disc, the Saturn, other versions of the game, and trying to take those objects and get back to code, get back to sprites that are editable, and other data, partially so that people can mod the game, but also so that we can get a better understanding of the code and how games of that era were made. What we've been doing on Made Up of Wires in the last week is looking at one of the weapon objects and taking functions for various weapons that have not yet been decompiled, and then going through the process of decompiling those. So to decompile, we look at an object that's on the disk that was shipped in the retail version of Symphony of the Night. Use some tools like Splat64, which is used to split up those objects into various segments containing image data, sound data, code, data supporting that code, and then taking data that is code and converting that into assembly language. Once the code is in assembly language, we have an opportunity to take that and using tools like decomp.me and some other decompiling tools, convert that back into C, which is the original language that Symphony of the Night and most PlayStation games were written in. If you want to find out more about this project, you can go to SOTN.z.dev, where there's progress for different objects that are currently being decompiled in the game. The main game engine, dra.bin, which is missing, I believe, one function. The Richter program is 100% decompiled from a code perspective, but now there's actually a PR out as of this morning that is working on getting all the data decompiled. We're going to be working on weapons in the Weapon 0 object, and that is in progress. 95% of the functions are completed, 70% of the code. And then there's several stages, many of which have been completely decompiled. So like I said, we're going to be working on weapons today. The primary tool, backing up a little bit, if you want to learn more, even more about the project, there's a GitHub repo Xionimo SOTN Decomp. That is where the majority of code changes are being done. If you go back to soten.z.dev, there's also links to Discord where people are talking about things that they've found, modding opportunities, different versions of the game, etc. So our goal with decompiling is to get some assembly, convert it back into C code, and have that C code compile back exactly to the assembly that we started with. And then taking that compiled code, combining it with all the assets and other things that were originally in that object to create a file that looks exactly like what was on the disk to begin with. And so for the modules for PlayStation that have been worked on, we do have projects like, or targets like that. So here's the ones that are currently being done for PlayStation. And these are all things that they might maybe pulling in some of the assembly code, but they all eventually get back to exactly what was on the PlayStation 1 release disk. We are going to be looking at weapons. Like I said before, we're going to primarily be using a tool called decomp.me to help us do an initial decompilation, and then going through that C code produced by the decompiler, finessing that down to create something that can be recompiled back into the same thing. So first we need to find a function to decompile. Those are extracted into an assembly language directory, so we're going to go look for things there. We're looking at the US version, we're looking at weapons, and we're going to look for non-matching things. Those files end in a .s, and we want to get a listing of each of those files. So here's several that haven't been decompiled yet. Each one of these is a unique function. And so we want to find one that we're going to work on today. We're going to just choose the smallest one that hasn't been decompiled yet. So we're going to take the size, we're going to take the name, and we're going to sort. Oops. And that gets us to entity weapon attack of weapon 33. We'll take a look at what weapon 33 is here. So the nunchaku, this is the only function remaining in this for this weapon that hasn't been decompiled yet. When a function hasn't been decompiled, there is an include ASM macro that Splat64 generates with, sometimes we get a nice name because somebody has gone through and decided to name that symbol. Other times we get things like function pointer 8017004, which describe the memory address where that particular function lived. So in this case, we do have, though, a entity weapon attack. This is a primary entry point for weapons when they're doing an attack. And so let's pull up the assembly side by side, and we can see what this looks like. So this is the assembly for this particular function. Some humans can read it. I am not one of those humans. So we're going to take this listing and go back to decomp.me and start decompiling. For the Castlevania Symphony of the Night project, there's already presets for PlayStation and PSP. This is the PlayStation version that we're looking at. So we're going to choose PlayStation as our platform, the Castlevania Symphony of the Night preset, and then paste our assembly there. The other field for setting up a new scratch is a context. A context acts like a header file that would be included if you were writing this in C, with definitions, macros, and other things that the decompiler can use to try to understand what structs, what pointers, what function signatures might be used, and that helps it determine types and variables and other things as it's decompiling. So once we've got that in there, there are tools for creating this context, but decomp.me will reuse the last one that you created. I believe this is one that I've been using for most of these weapons. If not, we can modify it as necessary. So we'll create the scratch, and the decompiler will go through and try to give us a best effort decompilation. And in this case, it can't figure certain things out, so we're going to get a bunch of errors that we're going to have to resolve. The first one is, just to go over the decomp.me interface quickly, on the left we have the C code that we are going to be working on primarily. On the right we have target compilation. This was the assembly that we just uploaded. And then next to that is what our code compiles to, the assembly that our code is going to compile to. We don't have any code that's compiling yet, so we don't have anything in that column. Down below we have all of our compiler warnings. Those are things that we're going to have to resolve. So I usually like to start out by getting the code to compile and then working on finessing it towards the assembly that we need to match. So the first thing is this set sprite bank 1 function. I happen to know the signature for this, but if I didn't, I'd go back to my terminal and look for other instances of this, and copy the signature back to the context. This isn't something that's part of the code that we're decompiling, so I move these into context and get them out of the way. Likewise, set weapon properties. We need the signature for that. So we can go through, find examples of that, and copy that signature in as well. And move that to the context. Next we have some global variables where the type is unknown. Had we had those signatures in place, at least the set sprite bank signature, the decompiler would have been able to figure that one out. So we can click decompile in decomp.me, use the new context that we just modified, and get a new decompilation. And that gives us the type of that first global. And then we'll look at the second one. This one we don't know yet, but inferring from the line that it's used, it appears to be an array of unsigned 16-bit integers. And that's just a guess based on what the decompiler did. I'm going to put that in there. Sometimes decompiling is a lot of guesswork, and so you go based on hunches from what you see the code doing, and then based on that, you either get closer or further away from the target goal. So we still have a bunch of problems. So sometimes the decompiler doesn't know what different variables are, what types they are. This case may be related to this variable, so we can move this into context too and try decompiling one more time. I like to get as close as possible with the the automated decompiler, because sometimes it's useful to go back to that version if you're getting further away, and that didn't really help. So we can start looking into these other errors. So we're setting it looks like an offset into this particular global variable. We can move that back into the source, where we can modify it if necessary. And taking an offset of C, which is 12, index 12. This could be struct access, and it may be that we're not actually accessing unsigned 16-bit integers, but that the field at the 12th offset is a 16-bit value. That's not clear yet. So let's change this to a pointer to a (16-bit) unsigned int, and we'll treat that as array access for now. And if we learn more about this later, we can always go back. And kind of similar for these, we're going to go through and just treat all these as array access. When there's very structured access like this at certain offsets, it's likely a struct, and we just don't know what the shape of that is yet. So I'm just going through now and finding all these places where this temp S2 is being loaded and replacing those with offset access. Again, the goal is to try to get things to compile first, and then go back through and fix anything that's necessary. One thing that I know that I'm doing wrong off the bat is 16-bit integers have offsets in multiples of 2, but I haven't been dividing by 2 as I've been going along, and so those offsets will end up being wrong, and they'll need to be fixed. It looks like I screwed up syntax here. Okay, so now we have something that's compiling, and we're 60% of the way, a 60% match to what the original version of the assembly looks like. It's not great, but not that bad. Once things are compiling, the next thing that I like to do is go through and update some of the arguments and variable names to follow conventions for the rest of the project. So functions that operate on entities typically will take an entity as the first argument. Those are very similar to methods in an object-oriented programming language. The decompiler will call them arg0, but for the context of this project, the idiom is to call them self. This isn't used likely because there may be some other C++ code that uses this in the future, and this is a restricted word or a reserved word in C++. So we'll go and do that. The next thing is there's several of these global variables that start with player underscore. These are addresses that have been mapped in the config for extracting code from the original objects as a convenience to the person decompiling. But when those fields are accessed, they're almost universally accessed as struct members and not directly by the address of these symbols. And with few exceptions, we're going to, actually all of these, we're just going to get rid of all these right away. And that'll give us some more errors. But we can go back and fix all those. And so what we're looking for now is places where there's player underscore. And we're just going to replace the underscore with a dot to get our struct access. And that will likely get us closer. Sometimes it gets us further away initially, but I'm hoping it gets us closer to start. Why don't I use a universal search and replace for this, because I don't like to think that hard. Okay, we still have a few failures. Often it's not just that first level struct access. We actually have to go a few levels deep. Some of these are unions that we'll try to change in the future. Line 33 is our last one. All right, so we were at 60%. Changing that to struct access got us to 72%, and that is a nice win. We have this other G player, unknown 46. That's going to be the same thing. That one we can replace because that's not going to overlap with anything else. Of course I say that in it, and then it doesn't work. Let's see. Line 5. Oh, so we can get rid of that now. Not really any closer, but not bad. The last thing for cleaning up right away is this hand ID is a global that's not part of this, so we'll move it into the context as well. We need the declaration, but we don't need it in our project. Okay, so now we're at 72%, up from 60. I see some issues down here. There's a few more of these where we're using direct variable access where we need struct access, so I'm going to go fix those up too. Anything with the GAPI prefix, those are going to be struct access as well. Sometimes that affects how those symbols are loaded, sometimes it doesn't. That actually got us a little further away. In some cases, when we replace a symbol where we have the original symbol name that would have resolved directly to a memory address, and we replace it with struct access, the decompiler is going to see that we have this GAPI variable, and we're taking some offset into it, some known offset, which is the play sound effects function, which is a field in that struct. We know that GAPI plus the play sound effects function will ultimately come up with the same address as GAPI underscore play sound effects. The decompiler doesn't know that because it doesn't know what the address of GAPI is. If we look at that line, of course that line that I chose isn't there. We'll look at line 33. If we put the underscore there, the addresses on these lines in our target and ours are going to match completely. When we change that to struct access, we get a difference, and it's the immediate value of that offset. We know as somebody working on this project that those things are the same. The compiler will know that those are the same. Decomp.me doesn't have a way to know that those things are the same. So we'll save there and then keep going. So one of the things that I noticed up top here, when we have a what we think is a array of 16-bit integers plus some other value, that is going to be effectively array access into that structure. We can look over here and see what is being generated and try to emulate that. I'm still concerned about the shape of that field, though. I don't think it's going to be an array of signed 16-bit integers. I think it's going to be an array of some struct, which is going to have at least 12 integers in there, or 12 fields, or sorry, 12 bytes worth of fields. I'm not going to touch it yet. That may or may not make other things more difficult, but we'll see as we go along. Let's try to clean this line up. There's a lot of casts. Often the casts are unnecessary and point to either the decompiler not knowing what types are, or us having the wrong types. So this particular field is already an unsigned byte, and so we don't need to cast. Some of this, when decompiling, is just cleaning up what the decompiler has done, giving things names, writing code in a way that a human would write the code, to make other modifications easier for us as we go. Just as personal preference, I like just taking that check out. Of course, deleting the parentheses doesn't help. So we have a preamble to see if we're going to go into steps. And then, so if we're at step 0, we're going to do some logic. If we're not at step 0, we're going to do some other logic. If we didn't do this preamble, we're going to go down here. Let's change the structure of that a little bit. That's going to destroy the entity. We'll get rid of that. Where did I screw up? Oh, so we're going to block 13. I'll leave that block there, or the label there for a second. So when we have gotos in the code, this code base in general does use gotos in some places, but if there's one area that's using a goto, it's often not actually a goto, but the decompiler can't figure that out. So in our block 13, we're destroying the entity and then we're returning. We only have one place that is jumping to that block, besides if we fail this outer conditional. So it's likely that the compiler saw that this is the same logic in these two places, and so we're going to reuse it. But the original code probably duplicated that logic because that logic is really simple and doesn't need to be shared. And then we can change this here to an else of this original. And that didn't get us any closer, but it didn't get us any further either, and it's easier to read. Just going through, still kind of looking for common idioms that that may be at play here. There are certain tricks and things that the decompiler may struggle with. Whenever we see step incrementing by 1, that usually can safely be replaced with increment operator. There are some times where, while as humans we think plus equals 1 and plus plus are the same thing, the compiler treats those different, and you'll see a bunch of code fall into place after that's been done. In this case, nothing happened. I'd say maybe 30% of the time, maybe less, that actually does affect how the code compiles. Anything else here? Let's clean that up. It looks like we're going to have to look at this struct here pretty soon. I'll leave those casts in for now. And take this out. Oh, I just screwed something up. Oh, I must have accidentally deleted something along the way. One thing I didn't do at the beginning of this project, my context includes string copy, string compare, string length, mem copy. Those are things that are provided by the PlayStation 1 SDK. We don't want the compiler built-ins, so I usually remove those from the settings. I could probably get rid of them from my context, but adding that option does the same thing. All right, 46. Okay, so in line 46, so this again points to this being a struct as opposed to an array of unsigned values, and this actually may help determine what these fields are as well. So let's look at the signature for update unarmed animation. So it looks like we're taking frame properties and frames, and this actually might have the what struct that is. So we have this anim variable here. Which is a weapon animation, which makes a lot of sense. So this likely is a weapon animation, an array of weapon animations, and fortunately, in this case, somebody has gone through and figured this out prior to us needing to, and so we can base what we found, or base our work on what they've done in the past. So instead of a array of signed 16-bit integers, we'll change this to a weapon animation. And likely it is of size 2. It might be longer. Now we're going to have to go back through, though, and change all of our array access back to struct access. So here we're going to have a weapon animation pointer. And we're going to replace all the temp S2s with. One of the nice things about these existing, or the remaining weapon functions that need to be decompiled, there's a lot of duplication and repetition in how they're structured and how they're written, and so we can fall back to code that exists already when we need hints for places that may not make sense, or anything basically that anybody has already figured out in the past. Okay, so let's see, we've changed that. Let's go through and change these fields. So we need to know what the shape of that weapon animation looks like and what each of the fields are at each of the offsets that we have. So we'll go back through and find that struct and what that looks like. For people who use IDEs, this is simpler for you. I tend to use Vim and just plain text editors. So I don't have the luxury of IntelliSense. I have grep and other things like that. So what? No, I want to include. And we're gonna paste this into our editor here for reference. Years and years of Vim key bindings will ruin you for other editors. So now we have a nice reference for all of these other fields. So we know that, for example, the Cth offset is frame start, and it's a unsigned 8-bit or a byte, unsigned byte. When we're looking at that throughout this code, it's being stored in this tempv1 here, tempv1 here. Let's look for other instances of that. It's likely that that was never pulled out as a value to begin with, and so we can go directly to that. And then check to make sure that that is going to get us closer. Let's not do that quite yet. Because we're not compiling. Let's get to compiling first, and then we'll go through and change those things. Okay, so line 39. We're at offset 8. Offset 8 is the palette. Of course, that makes a lot of sense when we're setting the palette. Okay, 45. 45, we're looking at offset C, which again is the frame start. 48, offset A. Offset A was the sound ID. Makes sense for a sound effect. Leveraging these structs that other people have already found, standing on the shoulders of giants, a lot of this starts to make sense, and we can see that, oh yeah, it makes sense that this would be a struct whose sound offset is at, or sound field is at offset A, because we're passing it to the play sound effects function. Unfortunately, somebody's gone through and determined that that function is responsible for playing sound effects, and then named these fields appropriately. So now we need offset 4 and offset 0, which is frame props and frame, and these are the ones that kind of were the trigger to finding these to begin with. Missed one at 47. Offset D is sound frame. Sound frame is used to match when the sound effect should play during the animation of the weapon. So before we started all this, we were at 72%. Changing this to struct access got us to 74%, so 2% closer. Not a significant win, but we know that this is closer to the shape that we're looking for. We also know now that this is an array of weapon animations. So we'll rewrite this as array access. Often the mask that's used here is produced by the decompiler, or produced by the compiler, and not something that we have to worry about specifically. And we're looking for a reference to that location rather than the actual struct that was there to begin with. Let's go back to this line to see what the assembly looks like before and after. So here is what the decompiler produced, and then we're going to change that, and not quite what was expected. We have a shift right. It's possible that this... So this shift right isn't being done. I'm going to... Let's see. So we're shifting right and then masking, and so we have the mask here. Try adding that back in and see if that changes anything. It doesn't. So this was a guess. Now we're backwards. So what I'm doing is modifying these values and watching how the disassembly changes, what these offsets are. The offset values, or the immediate values that are generated by the compiler, aren't always what you expect, because the compiler will try to optimize the shifts and masks to what is best suited for that particular architecture. So one thing that may be valuable is pulling this out into a variable and doing this separate, where we can kind of control this outside of the... okay, so... Yeah, this is backwards. Why? I'm going to come back to that one. So one thing that we're seeing too on line 22 here is that we're using byte access However, it's being treated as a 16-bit value. I thought entity params was a 16-bit. It is. And maybe that's because other shifting is being done. I'm going to come back to that. like that for now. Before moving everything over to the struct fields, I mentioned that this frame start being pulled out into a variable may not have been actually a variable, so we'll move that here. And does that change anything? That doesn't change anything, but we can get rid of that variable and reduce some of the surface area. Okay, so what else do we have here? So we have a few immediate values. So these branch statements, they're jumping to specific memory addresses. Those memory addresses are going to be different. So they're all going, in this case, offset 204, in our case, 1E8. And that's because we're missing some instructions here, down here. And so when those branches happen, here's 204 in the target. Ours was at 1E8, and there's actually some difference here that I didn't quite expect. Some code that is happening. So it's likely that these are being done outside of this block. And possibly this as well. Yeah, so that got us much closer, 78%. We still have a few things. That are missing. So our line 56. Sorry, our line 48. Is missing some logic afterwards. And we actually get, we're not seeing the warning here. This animation frame index, I'm not sure why we're not seeing the warning. This animation frame index is a 16-bit integer. But we're comparing it to something that would overflow 16 bits. And the way that the compiler compiles this comparison is actually combining two different 16-bit equality operations into one 32-bit operation, because that saves cycles. So this is actually a comparison between both the animation frame index and the animation frame duration. It's comparing the frame index to 1 and the duration to OXC, which is going to be the same as 12. Sometimes I can type, not when typing in front of others. That boosted us up to 93%. This happens quite a bit in these weapon functions, where the decompiler can't figure out that it shouldn't be creating a comparison between a greater than 16-bit integer immediate and a 16-bit integer field when there's another 16-bit integer field following it. That's nice though. That helps quite a bit. And actually, that probably should be back up here. That got us to 95%. So line 62, oh, we want to return there. So now we have a bunch of immediate values that are incorrect. That goes back to struct access versus the offsets of known symbols. Not concerned. Anytime there's pairs like that, when you know that the struct access that you're doing is the same as the symbol that was being loaded, that's fine. So we do have a few immediates though that are wrong. So we're comparing doing an OR with 1 versus the original was with 12. So let's find that, line 51. Oh, that's because I got that order wrong. So that now looks correct. We're still missing an instruction somewhere. E versus D. Oh, we're just offset further up. That's okay. Okay, so 39. This happens quite a bit too. The decompiler will put Z priority after palette and flags. It gets set before palette and flags. There's a few register issues here. Does it? Maybe I'm wrong about that one. I don't think I am, but something else is going on. Line 30, we still have an overflow. So this is due to a mask that's being used. So this overflow, again, the decompiler doesn't know that effectively there is a macro that's used to set this value. Go to line 30. So what is a negative 7FFF0? That's not what this is going to be. It's going to be masked with OX8000. And let's try 10. It might be. There we go. So this is palette 16 or OX10. So we're back here. These are out of order. Palette is usually set first. There we go. I chose Z priority to reorder, but it's actually palette that's out of order. So reordering that was enough, and that aligned that section as well. So there's still some immediate values that are not working. This is probably the same thing. So palette has offset 16. So we'll reorder that, not that way, but that way. Okay, that's closer. So there's this missing shift. We'll have to go through and probably figure that out next. I think that's the last remaining piece. So params is kind of an opaque 16-bit value. Different bits in that 16-bit value have different meaning depending on the context, and they're extracted and then used as indexes and flags and other things like that throughout the code. And so now what's left, it looks like, is trying to find the right bits to extract, then to use as an index. And I'm going to go through and look for a few examples. The one that I'm looking at for off-screen, I'm looking at weapon 39. So it's masking the first assigned 16 bits and then shifting over by 8. We can try that and see. So that was perfect. Who do we have to thank for that? Me. I was the person who decompiled entity weapon attack in weapon 39. Good job, me. I did not plan that, I swear. Okay, so now I'm looking at the target and the current, going through and checking to see the immediate values that are left that aren't matching. Is that the only difference that exists between target and current? If it is, then I'm fairly confident that this code is going to match when we add it back to the project. So far I don't see anything else. All right, that looks like it. So what I'm going to do now is save this. I'm going to go back to my repo with this code. I'm going to go to, which weapon was this? 33. And replace this include ASM line with what we just created. I thought I got rid of that comment on there. Before I do that, I want to make the project and make sure that all of the objects that are being created for this US PlayStation version currently match. And that way I know that I'm starting from a sane point and that anything I introduce at this point forward is my fault, and I have a good state to fall back to. So I'm going to get rid of the include ASM line and paste what I have in there, and then I'm going to build again. And we have some variables that are undeclared. This I know is a global that is going to be called animset, and compile again, and everything matches. So that means we took the assembly, massaged it around in decomp.me, got everything matching with the exception of some immediate values that were known struct offsets, and now the code compiles and matches what was in the original PlayStation version of the game. That doesn't mean, however, that this is complete, though. There's certain things that a reviewer is going to look for to accept this code into the project. First of all, we have a palette. I accidentally used the palette overlay macro here on line 24. That's actually going to be an animset macro. And this animset macro does exactly the same thing. It ORs the value that you're passing in by with OX8000. Instead of using the overlay palette for this weapon, we're using a palette that's defined in the Dracula object. So we're going to use that macro. For flags, we have access to lots of flags for for various things. Is this a... So it looks like this may be related to fall speed. I don't see any other value with that. But I haven't used that flag for any weapons. So let's just see if that's being... It's not being used elsewhere. I'm going to use it, and maybe one of the reviewers will know what that flag actually is supposed to be. One thing that the decompiler will do is when there's unions, this ext field, I'll get rid of this. This ext field in the player struct is a union with various structs for all the different entities that. So basically, at the end of entity, there's a blob of space, and each entity has its own shape that it uses that blob for. The entity that we're using now is a weapon, so it's likely that these are weapon-related fields, but let's look at the entity struct, or the weapon struct, and see if that makes sense. So we're looking at offset AC, which is animation. So that, yeah, it's it may not be specifically the weapon offset. It could be, is there an ET player? It could be the player offset. Let's make sure that's working on the player. That works as well. Accessing it through the weapon layout seems odd on the player struct. The offsets are the same. Many of the offsets for different entities are the same. They have very similar shape. So when writing in C, you don't have the ability to subclass and rely on offsets of fields that are defined by your inheritance hierarchy. So things like this, where unions of similar layout are used on top of one another to get a pseudo object-oriented feel. Let's see if any of these other generic. So there's another one. Where was I? So this stub extension, this is just a blob of bytes when nobody knows what else it could be. This is a guess, but that works out to be the same thing. I could be doing this in decomp.me, and I may go back and paste this implementation in decomp.me, just so there's a more public representation with the correct fields. But I like editing in Vim more than I like editing in decomp.me. So this is how I do it. You don't have to do it the same way. I can get rid of some of these casts. Those aren't necessary anymore. The next one is this 60B. We can see if there's a macro for that, or an enum value. So there is. These were just refactored and committed yesterday, which is very nice because I spent a long time a few days ago looking through and trying to figure out what the offsets for each of these are. So this would be FEDCB, weapon swish. Again, just making sure everything's okay as we change it. And so that, the rest of this looks fine. I don't see any obvious macros or enumerations that I'm missing. So I think I'm happy with that as it is. So now we have the part of the process where we need to get this back up into the project. This was weapon 33, so I'm going to create a new branch. Weapon 33, see weapon attack. I create this based on my personal GitHub fork, which I pull down Xeonimo's fork and merge it before I submit these patches. So we have the one file that's changed. When we look at what has changed, we have, we're getting rid of the include ASM. Our function is defined, so that's what we want to stage. Before, we can commit this. Before submitting it for a PR, we want to format it, make sure that things that I like to do as my own personal coding style don't get in the way of the project style. And it did. So when the formatter runs, it's going to go through and try to clean up orphan symbols. There's an issue right now with symbols in the HD version of the main game engine. Those in the future, hopefully this won't have to be ignored, but right now they're ignored. So what are the things that changed? So I like putting all my conditions in a conditional statement on separate lines. There's actually, no, that's fine. The linter will come through and throw all those on the same lines. There's ways for formatting arguments for function calls and things like that that I would do differently than the way the project is configured. The way the project is configured, fine. It's just is fine. It's just a personal preference, one way or the other. It's not right or wrong. So those changes are fine. We want to make sure that everything still compiles with those changes. Let me move that in parallel. I don't imagine anything will change. One of the things that the linter does as it's going through, it will touch a lot of files along the way, including ones that I didn't modify. And then those will have to be rebuilt. We'll try making one more time. Okay. In that case, it was more of a makefile issue where dependencies weren't resolved before the check was done, so that Dracula bin check didn't know that that file needed to be rebuilt, and so that rebuild happened after the check was done. So that wasn't actually an error. I've worked on some of that in the past and tried to resolve dependencies as much as possible in the makefile, the way that splat works and how it extracts things. It's hard to map all of those dependencies back to those config files, the symbol files, and things like that. Hopefully in the future I'll take some time to make that more sane so that things can be made in any order. Okay, so we want to add those formatting changes. And amend that, and then we're going to push that up to GitHub and submit a PR. So GitHub should know that I just pushed this branch. Great. We need a description. Unfortunately, for these, there's not really much to describe. It's a pretty straightforward decompilation process. I take this opportunity to go through and review these myself as well to see if there's anything that I, as a reviewer, would catch, especially since I know the things that are caught on my PRs pretty well at this point. And usually these are things like I was saying before. This animation set, is it being wrapped in a macro instead of being some ungainly hex value. Likewise, palettes are sound effects hard-coded values, or are they going to an enumeration or a macro that's been defined? So I don't see anything super obvious. So I'm going to submit, and Biz Murphy or Sozu will will shut me down in a few hours. Maybe not. We'll see. All right. So when the pull request is created, fortunately, this project is set up with a lot of nice automation. It's going to run the formatter to make sure that all the linting that I did already was done, because that's not an obvious step for new contributors. It's going to build various versions of the game. We were only modifying code that affects the PlayStation version of the game at this point, so it's going to build the PlayStation version of the game, Saturn, PSP, some other variants that exist, and just make sure that everything works once this code is in place. And so once those checks are done, basically then we're just waiting for a reviewer to come through and either approve it or add comments to it. Oh! Already, how could this... Too fast, too fast. Good call. All right, we'll get rid of that and push again. Thank you, Ziano. All right, so let's be good to our reviewers, and since they're active and paying attention, let's respond quickly. Look at that, even provided code for me. Good call on the animation set. So I'll make those changes. And send those back. I should have built first. Bad call not building before pushing back to the PR, but that happens. All right. So we'll go back to PR, and these will run again because there's new code that has been pushed. So earlier, submitted several more of these. That's kind of what I've been doing the past week, is going through, looking at what the lowest hanging fruit weapon function was, and submitting those. And Biz has been doing a lot of work. So here we have the one from yesterday. If you want to go back and watch the live stream from yesterday, you can watch that as well. We decompiled this one. Unfortunately, the audio was not working on that one. So if you do watch it, it'll be nice and silent. You won't have to pay attention to my jibber jabber. And earlier in the week then was a couple of them kind of aggregated together. If anybody has any questions about the decompilation process, this project, or anything like that, feel free to put it in chat. I have about 20 more minutes I can stick around and answer anything. Otherwise, I'll kind of walk through some of the other things that I have been working on in the project as well. My skill set, I think, lends me to contribute things that have to do directly with decompilation and maybe some of the work around taking data and just putting it in the right shape so that it compiles as C code instead of blobs of assembly bytes. Other people are much better at figuring out the shape of things and building structs and understanding how the game likely was set up so that we can build on it in a logical way and we're not just pointing at random offsets places. So kind of along those lines, based on the things that I feel like I can contribute, I've been working on this terrible function in the stage selection stage. I'm at 98.86%. What seems to be missing is some data types and some access to, or some ways that different addresses are accessed related to setting up streaming movies. So later tonight, I'll probably, not on a live stream, but just in my free time with a stiff drink, go through and try to figure out what is missing with some of these values. One of the things that happened earlier in this live stream is changing the structure of the code will change how the compiler allocates registers, which is largely what a compiler is responsible for doing. But in some cases, we get code that looks like it is the same. It seems like it should work just like what was previously there, but different registers are being chosen than what the original compiler chose. And cases like that, it's often that it's not this particular line that is causing the issue, or even this particular segment, but something further down, unexpected is happening, either ordering of statements or maybe accessing the wrong field, or fields in unexpected order or different order. And so changing code further down can completely change how registers are allocated earlier in the code. And that's when certain things can become frustrating, maybe tiresome. There is a tool, and I actually have been using it the past couple days to find some of these cases, but it's called the Decomp permuter. And that will, I don't have anything to show with it right now, but that will take the code and do some of the tweaks that I was doing to that entity weapon attack function, reordering statements, changing mask values, how different addresses are accessed, either through struct access, through direct pointers, through various other things, wrapping things in do nothing, do whiles that will fall through but will kind of keep the compiler from looking outside of those blocks to allocate registers. It'll go through and kind of do several hundred of these a minute, whereas as human decompilers, we can only do maybe a dozen or so of those a minute. And sometimes I find interesting things that I would have never tried myself. Sometimes it outputs the stupidest things that nobody would ever do, but like the decomp.me decompiler, it doesn't have a broader context of the code that it's trying to decompile. So there's that function. I'm hoping to get that hopefully later this week, maybe early next week, and that would be the last function for the stage selection stage. Unfortunately, this particular function for setting up the intro movie is not in many of the other versions of the game, so there's not a lot to compare it to. Sometimes that's another thing that's done to help with decompilation, especially in these cases where incorrect registers are being chosen. We have the PlayStation portable version of the game that can be decompiled, and the way that decompiler works is different. It's not GCC, it's MetroWorks, so it compiles code differently. Comparing the two versions can often help identify tricky spots that decompiling GCC generated code wouldn't be obvious. The other one that I'm working on, and much further away, this one's mostly for fun, is the sprintf in, sprintf in the PS1 SDK. I like these because they're kind of old school POSIX functions that work and look a lot like older BSDs or even early GNU implementations, but they're very distinctly PlayStation 1 implementations, and they might look similar to other implementations, but they are unique for the PlayStation. And so it's just kind of fun from a historical perspective to go through and how would a Sony developer or somebody they contracted out to write an sprintf function for a pared down system that doesn't need everything that a full-blown Unix would have had at the time. All right, I don't see any chat, comment, questions, so I'm going to end it here for today. If you're interested in the project, you can go to sotin.z.dev, see the progress. There's a link to the GitHub, link to Discord. Lots of activity on the Discord happening every day. If you're interested in more decompiling, I'm planning on doing this every morning, Monday through Thursday, as long as people are watching or I have the availability. So like, comment, subscribe, do all the other things that streamers ask you to do. And other than that, that's all I have. Thanks for watching.